Question is, find the approximate value of the integral minus 1 to 1 x square plus 1 dx using Riemann sums with n equal to 10. Divide closed interval minus 1 1 into 10 subintervals of equal length. That means divide minus 1 1 closed interval minus 1 1 into 10 subintervals of equal length. Also compare with the actual values. Here the problem consists of two questions. First one is find the approximate value of this integral using Riemann sum method with n is equal to 10. That means divide closed interval minus 1 1 into 10 equal parts. Okay, 10 equal subintervals. Oh, okay. Here the problem consists of two parts. First one is find the approximate value of the integral minus 1 to 1 x square plus 1 dx using Riemann sum with n equal to 10. That means divide the closed interval minus 1 1 into 10 subintervals of equal length. Second part is compare with the actual values. Okay. Here the integral is integral minus 1 to 1 x square plus 1 dx. X square plus 1 dx. Here a to b means here lower limit a is equal to minus 1 and upper limit b is equal to 1. Okay, and f of x is equal to x square plus 1. The integrand f of x is equal to x square plus 1 and also given that n is equal to 10. Here given that n is equal to 10. Okay, closed interval negative 1 1 into equal length of 10 subintervals. So choose x0 as negative 1 and x1 equal to negative 0.8, x2 is equal to negative 0.6, x3 is equal to negative 0.4, x4 is equal to negative 0.2, x5 equal to 0, x6 is equal to 0.2, x7 is equal to 0.4, x8 is equal to 0.6, x9 is equal to 0.8, x10 is equal to 1. Once more, here we divide the given closed interval minus 1 1 into 10 equal length of subintervals. So choose x0 as minus 1. Next one is negative 0. x1 is equal to negative 0.8, x2 is equal to negative 0.6, x3 is equal to negative 0.4, x4 is equal to negative 0.2, x5 is equal to 0, x6 is equal to 0.2, x7 is equal to 0.4, x8 is equal to 0.6, x9 is equal to 0.8, x10 is equal to 1. Okay. By Riemann sum method, for finding the approximate value of the given integral using this formula, integral a to b f of x dx is approximately equal to b minus a by n into f of x1 plus f of x2 plus f of x3 plus etc. plus f of xn. By Riemann sum, the formula for finding the integral is integral a to b f of x dx is approximately equal to b minus a by n into f of x1 plus f of x2 plus f of x3 plus etc. plus f of xn. Here we know that the values of xi's, f of xi, for calculating this we use this table that consists of xi and f of xi rows. Xi means x1, x2, x3, x4, x5, x6, x7, x10, x8, x9, x10. Okay, x1 negative 0.8, negative 0.6, negative 0.4, negative 0.2, 0, 0.2, 0.4, 0.6, 0.8 and 1. Okay, and corresponding f of xi 1.64, 1.36, 1.16, 1.04, 1, 1.04, 1.16, 1.36, 1.64 and last one is 2. We know that f of xi is f of x is equal to x square plus 1. We know that f of x is equal to x square plus 1. Here x1 is equal to negative 0.8. Then we calculate f of x1. f of x1 is equal to negative 0.8 whole square plus 1. That is equal to 0.64 plus 1. That is equal to 1.64. We get f of x1 is equal to 1.64. Similarly, we calculate x2. Here f of x2, how can we calculate x2? F of x2 is equal to, here x2 is negative 0.6 whole square plus 1. That is equal to, negative is positive, square is positive. 6 square is 36, 0.6 square is 0.36 plus 1. That is equal to 1.36. Therefore, corresponding f of x2 is 1.36. Similarly, we calculate all the values up to x10. Okay. Using this formula, we calculate the required question negative 1 to 1 x square plus 1 dx, which is approximately equal to b minus a by n. Here b is 1 and a is minus 1. We put here 1 minus minus 1 divided by, here n is 10. We put n is equal to 10 into f of x1. From table we can write f of x1 as 1.64, f of x2 as 1.36, f of x3 1.16, f of x4 1.04. Similarly, we can write f of x10 is 2. Okay. That is equal to 1 plus 1, 2 by 10. Okay. 2 by 10. 2 by 10 into the sum of these values is 13.4. After calculating this, we get 2.68. That is integral minus 1 to 1 x square plus 1 dx is approximately equal to 2.68. Negative 1 to 1 x square plus 1 dx is approximately equal to 2.68. Okay. First part of the question is over. Now second part of the question is compare it with actual values. Okay. So we integrate the function negative 1 to 1 x square plus 1 dx in the actual method. That is equal to the integral of x square is x cube by 3 plus integral of 1 is x. Putting limit negative 1 to 1. We get 1 by 3 plus 1 minus of negative, putting negative value here, negative 1 here. We get negative 1 whole cube by 3 minus 1. Okay. That is equal to 1 by 3 plus 1 minus negative 1 whole cube is negative. This negative, we get 1 by 3 and negative into negative positive 1. That is equal to 1 by 3 plus 1 by 3, 2 by 3 plus 1 plus 1, that is 2. That is equal to 2 plus 6 by 3. That is equal to 8 by 3. That is equal to 2.667. Okay. In actual method, we get integral minus 1 to 1 x square plus 1 dx is equal to 2.667. And in Riemann sum method, we get negative 1 to 1 x square plus 1 dx is approximately equal to 2.68. Therefore, the error is equal to, error in these two methods is equal to 2.68 minus 2.667. That is equal to 0.013. The error in these two methods is 0.013. Okay.